This is lesson 5-2, prime factorization. Our essential question, how can you tell if a number is prime or composite? And again, you guys should be really good at this because we've been doing this on our number of the day. So here's an example of what we call a factor tree. And we've been doing these on the number of the day where we break a number down until it can't be broken down anymore. And then we write out our prime factorization. But we use exponents. So this would actually be 2 to the 4th power times 3. Because there's 1, 2, 3, 4 2's. So that's why it's 2 to the 4th power. And then there's only 1 3. So times 3. You don't need to copy that down though. Alright, we have 3 vocab words, and we've talked about all 3 of these words before. We have prime number, which has exactly 2 factors, 1 and itself. So that means it can't be broken down by anything other than 1. We have a composite number, which has more than 2 factors. And we have prime factorization, which means writing the number as a product of its prime factors. Alright, example number 1. So in each example, we're going to write the prime factorization, and we're going to do that by first completing a factor tree, and then we're going to tell if the number is prime or composite. So we have 18, and we are going to break down 18 into 2 numbers. So we're going to think to ourselves, what 2 numbers multiply together to equal 18? And there's a few different things that we could use, and they're all going to get us the same answer. But I'm going to go with 2 because I know that 2 goes into 18 because 18 is an even number. So 2 times 9 is 18. And I know that 2 is one of those prime numbers, and it can't be broken down because it only has 2 times 1 as its factors. So I like to circle that. But 9 can be broken down. And 9 becomes 3 times 3. And we know that 3's are also prime numbers, so they can't be broken down. So we circle those. And now we're done because all of our numbers are broken down. So we take our circled numbers and we write our prime factorization. 2 times 3 times 3. But we know how to use exponents, so we are going to do that. So we have 2 times 3 to the 2nd power because there's 1, 2 3's. Okay, so there's our prime factorization. And then they want to know if the number 18 is prime or composite, and it is a composite number because it has more than 2 factors. It can be broken down by something other than 1. Example number 2, we're doing the same thing. So we have the number 23. And we think to ourselves, what times what equals 23? So there is nothing that is going to go in evenly without giving us a remainder or a decimal. So our only option for breaking this down is 23 times 1. And 23 is a prime number, and 1 is a prime number because neither of those can be broken down. So that is our prime factorization, 23 times 1. And because of that, since 1 has to be in our prime factorization, we know that 23 is a prime number because it can't be broken down by anything other than 1. Example number 3, 243. So I know by going back to those divisibility rules that 243 is divisible by 3. Because the sum of my digits is divisible by 3. So 2 plus 4 plus 3 equals 9. And 9 is divisible by 3. It goes in evenly. So I know that that is a factor. So when I break it down, I'm going to break it down into 3 times 81, because 3 times 81 gives me 243. Now I know that 3 is a prime number and it can't be broken down, so I circle it. 81, I take those digits again, 8 plus 1 also equals 9, so I know it should be divisible by 3. So 3 times 27 equals 81. And now we have another 3, which that can't be broken down, so we circle it. And then I have 27, and we're in the same boat again with 27. We have 2 plus 7 equals 9, which is also divisible by 3, so I know it can be broken down by 3 again. So 3 times 9 is 27. 3 is a prime number, so I circle it. And then I'm down to 9, and I know 9 is 3 times 3. And I circle both of those. So now I have 1, 2, 3, 4, 5 3's. So that gives me 3 to the 5th power. And I also know that the number 243 is composite because I was able to break it down by something other than 1. And our last example, we have 45, and I know that 45 can be divided evenly by 5. So 5 times 9 equals 45. Now, 5 can't be broken down by anything other than 5 times 1. 9 can be broken down into 3 and 3. 3 times 3. So we circle both of those because they can't be broken down. And now my prime factorization is 5 times 3 times 3. Or if I'm using exponents, it's 5 times 3 to the 2nd power because I have 2 of those 3's. And 45 is a composite number because I was able to break it down by something other than 1. Alright, your practice problems, you're doing the exact same thing. Do a factor tree for 1, 2, and 3. Write the prime factorization and then tell me if it's prime or composite. Don't forget a word problem or question and rate your understanding.